Hi, Shauna. Okay, since it looks like we're not going to be able to meet today, I never heard back if 12 was going to work, and I'm going to go off and have some lunch then since I've not heard back from you. I can't meet at 2, as I originally said. I'm unavailable from 2 on to have kind of a private, quiet meeting the rest of the weekend then. So hopefully this will work, this video, and you can ask questions if you still have them. Okay, so again, as always, start in the eScience Labs tab. We're doing chemical bonding, lab 6 this week. And in this week, you have 5 different things that you need to review. As always, start with download of the APUS instructions. And when you open that up, you'll see, what to do. So first it says, access the 7.1 introduction, read and watch everything that's in there, answer any questions or practice quizzes that might be there. And then we're going to go to section 7.2, structural models. And I'll walk you through that in a second, but a couple of different things we're doing this week. This first part is structural models, where you're going to use your like cardboard, and we're going to be looking at covalent and ionic compounds, kind of some tips and hints as we make the covalent compounds. The yarn should be wrapped around a pin from each atom, because in covalent compounds, electrons are being shared. So you're going to be using push pins to indicate the electrons and yarn to indicate when they're being shared. For ionic compounds, where there's a complete transfer of electrons from one to the other, you move your little push pins from the metal, who's donating the electron, over to the non-metal, showing that the electron's been completely transferred. Just like with any Lewis structure, which is what we're doing here, structural models, pay attention that all octets or duets, if applicable, duets would be, for instance, hydrogen that has 2. Make sure everything is satisfied. If for some reason your kid is missing any of your push pins, you can improvise with substitutes for the push pins if necessary. Just clarify your improvisation when submitting. Take a picture of each model that you make. So you're making 1, 2, 3, 4, 5, 6, 7 models. You'll have 7 pictures that need to be done, or 7 models made, and you're going to have pictures of each. And you're going to complete table 2 and the post-lab questions to prepare for what's going to be asked in the lab 6 assignment. For each picture, include a label with your name, title, and name of the compound. I have to know what you're making. So the names of these guys, not their chemical formulas, but the actual name, such as sodium chloride. And the date, that needs to be listed next to a little sign next to each of these compounds that you're making. All 4 have to be legible, visible, and readable, or you won't receive credit. Save these pictures together within a single PDF document. So while you're going to have 7 different pictures you take of 7 different compounds, you're going to put them all in one Word document and then save it as a PDF. So you're going to submit one and only one of your pictures. And I'll show you that. It asks for that in the instructions in just a minute. So what I suggest is you work through that first and kind of put a hold here, and we'll come back and do the other. There's 2 additional things we're going to do in this lab: melting points and solubility. So start and just do one at a time so you don't get overwhelmed. So when we come back here, it said the first thing was then to go back to section 7.1, which is the introduction, and read and view anything in there. So this is a summary of chemical bonding: ionic electrons being transferred, covalent electrons being shared. And I'm not going to read, you can read through all this. You need to read through all this. Click play, watch all the videos, do everything that's here. This is your responsibility to go through all this. Hopefully this is a review for you. Intermolecular forces, you click next and watch that. Same thing here with covalent bonds. Click and watch the videos. Lots of things to click and watch. There's a lot of flash stuff in this one. Read through all this in 7.1. This is your introduction. And then when you're ready, you can do a little practice quiz here. At the bottom, as always, you can click here to download and complete the pre-lab assignment. But again, you're only uploading and answering the question. You're only required to answer the questions that's asked of you in the test and quizzes area, which I'll get to in just a minute. Okay, Then when you're ready, that first section, that first exercise, structural models, what I was just talking about, is right here. Exercise 1, structural models. So you need your cork board, 14 pieces. You need push pins. If they're colored or not doesn't matter, but you need push pins, yarn, and then the periodic table from the introduction, a ruler, and then on your own you have to provide the camera, scissors, and you'll need a permanent marker, something to write on the corkboard. So the first thing you're going to do is get your corkboard pieces, and you're going to create each of the following atoms. So for instance, the corkboard is a brown color, this is the corkboard, and you're going to, with your permanent marker, write an F for fluorine. And you're going to make separate, that's why there's so many of them, you're going to make separate corkboards for each of the atoms, and some of them you need 2. For instance, chlorine, you're going to label 2 corkboards with a Cl for chlorine. Sodium, oxygen, you're going to need 3 of them, 3 corkboards that have an O for oxygen. A magnesium, a potassium, a bromine, a fluorine, a hydrogen, you're going to need 4 corkboards that have an H for hydrogen. Then you're going to use your periodic table and what we've already learned about valence electrons from your post. It looks like you got in the discussion forum, looks like you've got a pretty good handle on that. Record how many valence electrons each atom has and record that. And there's a table right here that you can record. You're not actually going to submit this. Again, I'll show you that in a second when we get to the quizzes and tests and quizzes area. But you're going to need this for what you're going to do next. Okay? And then also it's going to ask you in a minute what type of bond these are because you have to label that. Okay, so the first thing you're going to do is create HCl. So you need a corkboard with an H written on it, and you need a corkboard with a Cl. And you're going to use push pins to represent valence electrons for each of your atoms. So hydrogen has 1 valence electron, it should have 1 push pin. Chlorine has 7, it should have 7. And so if you see right here, this was the example using fluorine. Fluorine is like chlorine, it has 7. And so 1, 2, 3, 4, 5, 6, 7 push pins around fluorine. So the push pins represent valence electrons. So the push pins are the dots that you used when you did Lewis structures. But instead of dots, you're going to use your push pins. Use your camera to take a picture of the results. Label the picture and send it to me along with answers to the post-lab questions. Well, you're going to save this for what you upload. Okay, what you upload in the test and quizzes. You don't actually email this to me. Okay, then you're going to put your corkboards together right next to each other to create HCl. So hydrogen is coming with its 1 electron, chlorine has its 7. You're going to push them together, and then, and you can do this step actually whenever you want, but you could do it initially at the beginning or you can do it right now. You want to use your ruler and scissors and cut the yarn you're given into 7 12-inch long pieces. You're going to need 7 pieces, so make sure that you measure with a ruler and do that appropriately. All right, now what you're going to do, so you're going to have pieces of yarn. You're going to wrap around and connect valence electrons that are being shared, and that only happens in covalent bonds. So that's why down here it's important to know what type of bond each of these has. If it's a covalent, you'll use a piece of yarn and show that their electrons are being shared. If it is an ionic, you won't use yarn at all because electrons are being transferred, and you'll actually pick up and move a push pin from the metal, such as sodium, to the non-metal, such as chlorine. All right, so once you've got your yarn, if it's again covalent, wrap around and show that they're sharing. If it's ionic, remove a push pin from the electron donor, that's the metal, and give that push pin to the non-metal electron acceptor. Use your camera, take a picture of the results. Make sure you identify, label the picture so I know what it's the picture of. For instance, sodium chloride, and that it's ionic. And you'll save that for what you're going to do in the test and quizzes area. Okay, then you remove the push pins from the corkboard. You're going to repeat all those steps for all the different substances. So you're going to do this many times. Yarn is used if it's covalent. Move the push pins from the electron donor to the electron acceptor if it's ionic. Make sure all of your pictures, all of your substances are properly labeled so that I know that you know what you're making. and then complete the second table. I recommend you complete the second table first, not at the end, so that you know, again, which ones need yarn, because electrons are being shared, and which ones you're going to pick up and move push pins. Now, just as an example here, let me show you. Oops. Still not it. So this is an example of what they look like. You need a sign with the lab date, the lab name, what the substance is. This is KBr, where it had 1 valence electron, but that's an electron donor. It donated to the bromine. Bromine initially only had 7. After potassium donates, it has 8. So this would be an ionic compound example. And here's a covalent compound example, where the valence electrons are not transferred from one atom to the other, but instead the covalent bond is formed when they're being shared. So you're going to make this type of picture for all of your compounds. Okay, and now let's go back to, let me go back to the instructions. Once you've done all that, you're done with exercise number 1. You're moving on to experiment number 1, melting points and types of bonds. Take a picture of each substance. There are 3 solids that you're going to study in this part: sucrose, sodium chloride, and stearic acid. Take a picture of each substance while inside its cupcake wrapper before and after you attempt to melt it. I need to be able to see what's inside the wrapper, okay, observable changes. And I need a before and after a picture with a label. And don't forget, on the label, you have to tell me which one is sucrose, which one is sodium chloride, which one is stearic acid. All that has to be visible, or you won't receive credit. You're going to save these pictures within a single PDF document, so you're going to have 6 different pictures before and after of all 3, but they'll be merged into one document. For instance, I have an example here somewhere. Where did it go? Like this guy here. Okay, he actually didn't do 6 pictures, he did 2. That's fine. You can do 6, you can do 2, it doesn't matter. But you have to somehow label what the before looks like, so you can see the solids that were taken out of the container inside the foil cupcake wrapper, and then after he melted them, again labeled, this was stearic acid, this was sucrose, and this was sodium chloride. Okay, and then if we come back to, let's see if it'll let me here. Got to go back out and back in again. And so here's the actual experiment. Everything you're going to need, what you need to provide. You can read through these instructions. Basically, you're just going to, get your foil wrapper, get your solid, take a mass of, you only want to use 1 gram. You're not recording the mass anywhere, but you don't want to use too much. So weigh out approximately 1 gram of your solid, of the sucrose, the sodium chloride, and the stearic acid. Predict which one you think will melt first based on what we know about intermolecular forces. Record your prediction. Let's see, fasten the ring on the stand, cover the ring with foil to create a platform to set the cupcake wrapper on. You want this to be about 3 inches above the surface you're working on. You're going to get out your sterno fuel, your fuel canister. You're going to heat that, you're going to get that going so that it's heating up. And again, you can kind of read through the rest of this. The sterno is going to provide the heat to heat up that solid. You're going to heat it up until it starts to melt. And it says, take your stopwatch, record how long it takes for it to melt. If it doesn't melt after 5 minutes, record it did not melt. Now, some students report none of them melt. That's not true. If your heat source is too far away from the cupcake wrapper where your solid is, it won't melt. So you need to make sure that you follow these instructions, that you're approximately 3 inches, no more, no less, above the surface. All right, see how long it takes to melt. Repeat that same thing then with the sodium chloride solid and the stearic acid solid. And again, you can read this. At that point, you're done. You can extinguish the flame. Right, record how long it took each compound to melt, the order, meaning which one melted first, which one melted second, and which one melted third, and then indicate what type of chemical bond, covalent or ionic, each substance has. And then finally, if we jump back over to our APUS instructions, we're going to be doing things involving solubility. Solubility. So you're going to take a picture of each substance. Again, the same 3 substances we just did melting point for. You're going to test their solubility. You're going to have 3 separate test tubes. One has sucrose in it, one has sodium chloride, one has stearic acid. And you're going to take a picture after you've added 15 drops of water. Complete table 4 in preparation for this. If your test tube is not clear, I can't see the contents, you can transfer it to another. This usually is not a problem, such as a small beaker, but ideally leave it in the test tube. The solid sucrose plus water will be 1 test tube, sodium chloride plus water another, and stearic acid plus water a 3rd test tube. In each picture, I have to have a label with your name, the title of the lab, and what compound it is, and that it's in water, because you're going to do some other liquids as well. So 3 test tubes labeled with in water written somewhere on them, so I know this is your solubility in water. Okay, and then you're going to do the same thing. You're going to reload, and I'll show you that in a second here, with the same 3 solids. So you're going to dump out your test tubes, clean them out, then add sucrose, sodium chloride, stearic acid again to the 3 separate test tubes, but this time you're going to add 15 drops of ethanol, which is an alcohol. Notice and see if any of them dissolve in alcohol. Same steps then as before. They need to be labeled with what the compound is, and in ethanol, or even just in alcohol is fine, but so that it's very obvious that these are the solubility tests in alcohol. Also has to have the usual, your name, lab title, date, all that. And save those together as a single PDF. So you will have a single PDF with 3 pictures for this first step when you're doing the solids in water. Then you'll have a different file or PDF with 3 pictures in 1 document. These 3 test tubes, these 3 solids in alcohol. Okay? And then you're also going to do table 4. So let's come back. We did melting points. Let me go back out and come back in. Solubility, our last part here. So here's all of your materials. Again, I'm going to let you read through this. Basically, you're going to get 3 test tubes. You're going to put a small pinch, just with your fingers, of sucrose in one of them. Add 15 drops of distilled water, not tap water, but your distilled water. Swirl for 3 to 5 minutes and write down in this table whether it dissolved. Then you're going to do it again with sodium chloride and with stearic acid. Keep those test tubes, because remember, you need to take 1 picture that shows all 3 test tubes separately. So just set the test tube aside and then go to the next one. For each one, you're going to add just a pinch of the solid, 15 drops of the liquid. In the first run, you're going to use distilled water for all 3. In the second run, you're going to use alcohol. And then this is table 4 that you have to complete and say whether the compound was soluble in water, or if it was, or if it's soluble in the ethanol, which is isopropyl alcohol. Then when you're done, answer these questions, keep that off to the side, and then you're ready to go through tests and quizzes. And again, that's what it says right here too. You need your table 4 saved as a PDF, and you're going to submit that in your test and quizzes area here. You can do it by hand, take a picture, whatever. I just need to be able to read it. And then you're ready to do cleanup and go into your test and quizzes. So let's look at our Lab 6 assignment. When you're ready, click Begin Assessment, excuse me. First thing, and again, this matches our APUS instructions here. First thing, upload in PDF format a picture of exercise 1, the structural models. To receive credit, I have to be able to see all 7 models. In the picture, they have to be labeled with your name, title, name of the compound, and the date. And this is just 1 file you're uploading that has all the pictures. So that's what I showed you back here, what this guy did. Okay, he's got all of his different pictures in here. So that's what you need to do for part 1. And again, that matches the first thing highlighted in yellow for each picture you take of these models right there. Okay, question 2. Upload a picture of your experiment 1 melting points and types of bonds. Step 4. This is step 4 here. This was your before and after picture, which looks something like, oops, where did I put it? I had it here somewhere. There. With your cupcake, foil cupcake wrappers before and after of your 3 solids when you were melting them. Again, I have to be able to see the contents inside the wrapper. You have to label before and after, and a label with your name, title of the lab, name of the compound, and the date. One file with all of that in there. Click Browse and Upload when you're ready. Question 3, your completed Table 3, melting points and types of bonds. That was Table 3, the third highlighted section here. Save your completed Table 3 as a PDF. This is going to be your Table 3. Question 4, upload picture of your experiment. Number 2, solubility in water. To receive credit, I have to be able to see what's inside each test tube, as well as it being labeled with your name, lab title, and name of each compound. Remember, you're doing 3 compounds, and the word in water after the name. Okay, and that, just as an example, looks like this student did here. Sodium chloride in ethanol, sucrose in ethanol. I can see the test tube. She's got her label, all that. That was for the second one, but it would just be nearly the same, but with water for this first one. Then the second one is the ethanol, doing the same thing. 3 test tubes, has to be labeled with what each compound is and in ethanol. And then finally, Table 4, the solubility data. That was, come back here. Oops, I'm on the wrong thing. That was in the that was in your eScience lab. Table 4 was right here. Table 4, solubility data. You can hand draw this, you can do a print screen and fill it in, whatever, however you want to do it. The 3 compounds, yes or no, they're soluble in water, yes or no in alcohol. All right, that's it. I hope this helps.